Morning everyone, my name is Paul Lavelle. I'm with the Advanced Services team at Arista, and in this session we're going to be talking about enhancements in the CloudVision platform. Okay, in terms of the agenda, I'm going to provide a brief overview of the CloudVision platform. We then have a section, what we've called the CloudVision story so far. So we're going to look back at some of the major feature enhancements that have gone into the platform over the last 5 or 6 years. To serve as a bit of a recap. Then we've got a bit more of a closer look at some of the enhancements in the latest release, the 21.2 release that shipped back in September. We then have a look at the CloudVision Studios, which is the new provisioning workflow for CloudVision, bringing a new point-and-click interface for provisioning. And then we've got some time at the end if there's any questions around any of the topics that we've covered in the session. So, to start with a brief overview of CloudVision, quite simply, CloudVision is Arista's unified management and analytics platform for the entire enterprise network. So that covers the data center, campus, wired and wireless in the campus, but also hybrid cloud, internet and core networks as well. So similar to the case where we have a single operating system on the switches, we have a single management plane that works across multiple network domains as well. And there's really 3 key pillars of functionality within the CloudVision. First of all, it is a fully automated network deployment and management system. So that's everything from day 0, initial provisioning through to ongoing change control. We also have the real-time state streaming part of CloudVision. So we take the entire state of the network from our devices, stream that to CloudVision, and CloudVision is able to build a complete picture of the network. And third, we have network compliance and risk assessment. So by building this complete network-wide view, we're able to keep track of software and configuration compliance across the network, and also provide proactive risk assessments as well around software defects and bugs, etc. And the other main goal of CloudVision is to offer this feature set in a turnkey solution. So that means that customers can quickly deploy CloudVision within their environment and take advantage of what we call cloud class automation and visibility. Okay, so we thought it'd be useful to have a bit of a recap of the functionality within CloudVision. So the initial version shipped back in 2015, and it was offered as a software platform. You could deploy that within your environment as either a virtual machine or as a physical appliance. The initial release really set the foundations for the product. You get the web portal, so you can manage your devices through a secure web browser. But also, there was a REST API as well from the very first release, so meaning anything you can do through the web interface, you could also integrate with external scripts and tools. So it's not a closed system. You can integrate it with existing workflows. And the other main foundation that it set really was what we call the NetDB, which is this network-wide database concept. The initial release focused on provisioning. It had introduced some key features such as zero-touch provisioning, or ZTP. This allows new switches to be onboarded onto the network automatically and appear in CloudVision, ready to be managed and provisioned. It also introduced something what we call containers and configlets. So containers are a way of grouping your devices by location or role in the network. And you can build this tree that we see in this screenshot at the back here. And what you can do is apply what we call configlets, which are essentially sections of configuration to the devices. It's a combination of containers and configlets that allow you to reuse elements of configuration and apply them consistently across the network. And this has been a very popular way of customers managing their network with, as these scale-out designs are deployed. And we also have this diff view, so any change you make is presented to the operator to be validated. Here we see it's a little bit blurry here, but you see the side-by-side screen of a change. I think it's to add an ACL, and that's presented so you can see what the impact or what that the result of that configuration change will look like. We also included in the initial release image management, so CloudVision is able to deploy software, EOS software, across the switches consistently and keep track of which devices have which image applied. In the 2016 release, we added or extended zero-touch provisioning with something called zero-touch replacement, which is what this basically does is allow you to RMA or replace a failed device in the network, bring that device quickly back online, restore its configuration and image, and that's a built-in workflow within CloudVision. We also introduced something called configlet builders. This allows you to generate configuration dynamically. So there's a Python environment and a form-based system where you can enter network parameters to build configurations that way as well. That's been a popular tool with customers that wanted to introduce their own scripting and templating logic into the provisioning process. In 2017, we added change management. So we have a way now of grouping together our provisioning tasks into change controls. We also added snapshots, so operators can collect key metrics before and after changes, and that's presented back to the user for verifying changes. We also added network rollback, so you could restore the network to a known good point in time for a known good configuration. 2017, probably what CloudVision, one of the main features it's known for, really arrived in 2017.2 release. This is the streaming telemetry side of CloudVision. And this is via a software agent running on the switches. We stream the telemetry from all the switches, all the state changes, so that's every MAC table change, every routing update, various other metrics that are streamed off the box, collected in CloudVision's network NetDB. And we allow users to query and display that data in various views, either in real time or historically using a timeline selector. So what we see here in the background is an example of the state streaming of a metric here. And really, by having all this data within the NetDB, it sort of addresses two perspectives of network monitoring and visibility. You've got the case where you know what you're looking for. For example, you want to drill down on a particular interface or metric within the network. You can quickly select the device, select the metric, and view that information, and build dashboards around that. But we also have the case where you don't know what you're looking for particularly, and that's where we have what we call the event system. So CloudVision is constantly monitoring this stream of telemetry that's coming in from the devices, and based on a rule set within CloudVision, we're able to generate events and alerts and bring those to the attention of the operator. In the event screen here, what we see at the front screenshot. One of the unique aspects of this is once an event is displayed on the screen and you can select it, CloudVision will also present other relevant metrics around that event at the time. So, for example, this BGP peer message here, we've seen a change in BGP peer state on a device. CloudVision automatically presents the BGP peer count and other relevant metrics for other devices, adjacent devices in the network. So that's very, very useful. And we can also forward these events to external systems as well. So we've got some integrations we can send via email. We've got some other integrations with some chat tools and things like that. And that's something we're adding more capability around as well. In 2018, we added the network topology view to CloudVision. This allows operators to see how their devices are interconnected using LLDP discovery. But a unique aspect of this, it's not just a network diagram. We can overlay the various telemetry data onto the screen with what we call overlays. So, for example, here we can see which links have alarms or events for them. We can also overlay bandwidth utilization, error counters, etc. Drill in and cross and correlate between events. So if we click on a link, that takes us to the particular interface, and we can switch to different metrics from there. We also introduced the compliance dashboard in this release, so we can keep track of, as I mentioned, configuration and image compliance as well within the network. Flow tracking was added in 2019. This works by streaming S-flow or IP fixed data from the switches. We stream that to CloudVision using the telemetry connection that I mentioned. And then we can visualize this data in various ways. So we can drill down, we can select a source and destination and find the top talkers, etc., and display that S-flow data within CloudVision. We further enhanced this in the 2020.2 release with what we call flow tracking visibility. So once we have this S-flow data or IPFix data, we can overlay this onto the topology screen to show the end-to-end path particular flows are taking across the network, which is particularly useful in these scale-out designs where you have multiple spines, as was mentioned in the previous presentation, so we can see which path traffic is taken end-to-end, and also correlate that with other metrics such as bandwidth and throughput, etc., and events. And finally, in this section, we've got 21.1 release, which was April this year. We added what we call dashboards, a new way of querying and displaying this telemetry data, so customers can build their own metrics dashboards and save these and then recall them later. So, for example, you can build a dashboard maybe for the NOC, monitoring key devices or key links, and recall that simply from the interface. The other area enhanced is scale and performance of the CloudVision platform over the various releases. It's interesting to look back. 2015 release was supported 100 EOS devices, and you can see over the subsequent releases we've enhanced it, the system in various ways. We can now make better use of the underlying resources within CloudVision. We also have we've migrated to a container-based architecture. So under the covers, where CloudVision is now using a container, a scale-out container architecture, and we've also have released new versions of the physical appliance, the CloudVision physical appliance. So this is latest generation is the 250 series, sorry. And as you see, the latest release now supports up to 1,000 devices, so 10 times the original scale, and up to 100,000 monitored interfaces. So, and that continues to be the trend as the releases go forward. Scale is another major focus. As Miguel mentioned during the introduction, we've also introduced, I think it was August 2020, we announced CloudVision as a service. This is a cloud-based offering for the CloudVision platform. You get the same telemetry and provisioning as you do as the on-premises, but the key difference is this obviously runs as a fully managed on Arista hosted and managed infrastructure in the public cloud. So benefits of that include, the deployment time is reduced because you don't need to install the platform yourself, provide the compute resources. That's all handled by Arista. The devices, the on-premise devices, stream their telemetry over a secure connection over the internet back to the web-based CloudVision instance. And the other key benefit is you don't need to worry about upgrades because Arista handle the periodic updates, so you always make sure that you'll get the latest enhancements as they're released automatically. No need to upgrade. Okay, so now we've had a recap. What we'll do is have a closer look now at some of the enhancements in the very latest shipping release, which is 21.2. This was posted on the website in September. I think it was the 7th of September. This is now available for download and upgrade. So if you're an existing CloudVision customer, you can go through the usual upgrade process. I want to draw attention to a few of the main features, and we'll look at these during the session in a little bit more detail. First of all, we have an updated events screen. I mentioned the events capability within CloudVision. We've redesigned that interface to make it improve performance and improve the user experience of that view. We introduced change control templates. So as I mentioned, we have change control for our provisioning workflows. We now can build repeatable templates. So if you've got a common task that you want to deploy, maybe rolling out a new VLAN or adding a new switch into the network, and you have a standard process around that, you can now build that as a repeatable change control template. We also added in-band telemetry. So I mentioned we have IPFix and S-Flow integration. We now can extend that to include what we call in-band telemetry, which is available on some of the new switch platforms. We'll have a quick look at that as well. We added some options for integrating with external authentication providers as well. So if you use, for example, Google or Microsoft authentication, you can now integrate that directly into CloudVision and log in with your credentials. We integrated with Forescout as well, so we can manage segmentation policies through CloudVision through the same interface. And finally, there's CloudVision Studios arrived. This is in beta status. We'll cover this one in a bit more detail, and Hugh has a demo walkthrough of this to show you some of the new screens within the provisioning. As with all releases, we publish what we call TOI, Transfer of Information Documents, on the Arista website. So it's eos.arista.com. There's a TOI section, so you can always go to that area on the website where you'll find detailed information on any of these features. So this is one of these features that stands out, something you want to know more about. That's a great reference there to go and look for information. Okay, so first off is the new event screen. Got a new look in the latest release. When you first click on this page within CloudVision, you're presented with the last 24 hours of events from the current time. And we categorize the severity of the events that come in based on the telemetry data, from info, warning, error, or critical. And we show these in this chart. You can drill in and out from here, but that's the first page. That's the sort of the default view when you arrive at this page. We've added various filters in here, so you can filter for active alarms or alarms for particular devices. So down the right-hand side, you've got various filters. For example, you can filter on event title, whether it's acknowledged or not. And another big ask from customers is to acknowledge bulk acknowledgement of events. So we have that capability now. We can select multiple events at the same time and acknowledge them. Or as we see here, we can also export them to external a CSV, but we've also got ways of forwarding this event information externally as well. Okay, so in terms of the number of events we now support within the platform, we're now up to 49 telemetry, what we call telemetry-based events. So this is not SNMP based. This is all streamed event data coming in from the switches. So we automatically recognise 49 different event types. So there's a default set of events. You can see here on the left of the screenshot. So this is an event list that has been developed. The CloudVision team worked closely with our TAC and engineering teams to develop this as a base set of events that we recommend customers start with as a baseline, and then you can take that further and tune that to your environment. Maybe there's particular devices that you want to raise the severity if there's an event on those particular links or devices. We give that capability to configure the events. We also have 35, by default, 35 syslog-based events. So these are events that are looking for particular syslog messages. But you can extend this if there's, in your environment, if there's a particular feature or event that's of interest. If you know the syslog message from the EOS syslog guide, you can plug that into CloudVision and build a custom event around that. If you do click on a particular event, something we've added in the latest release, which I think is quite useful here, we still show the timeline of the event, so you can go back and see what was happening around the network at that point in time. But we also have added this info this button at the top. If you're not sure what the event is or you want more information, you can now click on this info button. And what we do is we provide a brief description, but also links through to the Arista website where the operator can find more information on that particular event. So it's a starting point, maybe before you need to engage TAC. It gives you a reference to look at for those events, and that's something that we'll continue to work with our TAC team to make sure that the events have the most relevant information and pointers. Change control templates. We've had the ability to build changes within CloudVision for several releases. For example, we can introduce maintenance mode actions before and after a change, or maybe run a snapshot to collect certain outputs before and after a change. But what we've not been able to do until this version is build these into a repeatable workflow. So that's meant often lots of clicks in the interface to recall those particular steps, which is not always the most consistent way of doing that between different operators. So now what we can do, there's a new option under the provisioning and change control section of the system. You can define a template, build the various stages and pre-populate them into these sections. And then any future change, you can then select that change control template, and that will apply to that change. That's promoting consistency in the changes that happen in the network. We have another popular ask from customers is change control scheduling. We did have this actually in previous versions. It was removed a few releases ago as we redesigned the change control system. It's back now by popular demand. A small feature but very useful here. When you now approve a change within CloudVision, there's a schedule button at the top where it says schedule for. By default, the changes say unscheduled, which means you manually click execute at that point in time when you want those to be deployed. But now if you click on the schedule after approval, you can click on, during the approval process, you can click on scheduling and you get the date picker and the time. And once applied and approved, maybe you want to make sure these changes are pushed after working hours or outside of core hours. CloudVision will automatically deploy the changes down to the switches at that point in time. So hopefully that's a useful feature. We have another small change behind the scenes really for configuration pushes from CloudVision. We now make use of a feature on the EOS side actually called the commit timer. So this is a feature that's been in EOS for some time, but CloudVision wasn't using this method for its config pushes. What actually happens is any change you make through CloudVision now is pushed down to the switches using the API connection. But what it does is it invokes what we call the commit timer. And what that means is if for any reason CloudVision was to lose access to the switch during the push of the change, and that could be for various reasons, you've maybe made a change to an ACL or the routing or the BGP policy, something has prevented CloudVision committing the change. What will happen is after 4 minutes, by default, it's going to be changed, but by default, after 4 minutes, the switch will reapply the pre-change configuration. So hopefully that will be the end of accidental loss of connectivity to devices during changes, which I'm sure some of us have had in the past. So it doesn't really show in the screenshot there, but what I'm trying to, it's just showing that the commit timer has expired during this change. There's been an error reported, and the original configuration has been reloaded. In-band telemetry is new to CloudVision 21.2 release. So we've had, as I mentioned earlier, we've had S-Flow and IPFix data for quite a while, but now we've got a new generation of traffic monitoring capability in some of the new platforms and software releases. So there's two main flavors of this. There's INT, stands for in-band network telemetry, and we've also got Green T as well. These are sometimes known as postcard telemetry. Green T is known as that. This does require specific hardware and software on the switches, so it's not available on all switches, but there's the TOI links that explain which platforms that's available on. But once the platforms do have this feature enabled, CloudVision will receive that same flow data over the telemetry connection. We now have a way of viewing that in-band telemetry data within CloudVision. So there's two ways to access this. There's through the global traffic flows page, which is on the devices tab. Now you can select in-band telemetry data as a source, and you get the usual source and destination IP addressing that you can search by or port number. But now you also have this latency metric as well, so you can drill down on flows that are incurring the highest latency, for example, within the network, and view that in various ways. either historically again or using the live view or the timeline view. If we click on a particular flow that the CloudVision knows about, you can see the hops that the packets have taken, and you can see latency metrics as well. So this is the data that's being driven by the in-band telemetry data that's coming from the switches. We can also view this in the topology screen. So similar to IPFix data, you can now view the end-to-end path and see which links are incurring high latency, or if there's hotspots in the network where particular flows are seeing a lot of latency. You can now see that and visualize that within the topology screen as well. Okay, a small feature we've added is integration with third-party OAuth providers. So up to this point in time, we've had the standard integration as most network tools do, with either local authentication but also Radius and TACACS. In the latest release now, via the settings page, you can now integrate CloudVision directly with these third-party providers. So you get the login, the Google login or the Microsoft login. This feature was actually originally available for the cloud-based, the CloudVision as a service. This is an example of a feature that has now moved to on-prem as well. So this is a feature that any version of CloudVision can now use. Okay, so now on to CloudVision Studios, which is our new or next generation provisioning workflow within CloudVision. So as I mentioned, we've had for quite some time, or from the very start, managing our configurations using configlets and containers. But that has required syntax knowledge, and to use configlet builders has needed some Python knowledge as well. A lot of customers have asked for the ability to have a point-and-click interface within CloudVision. So for operators perhaps that are don't need to know the low-level detail of particular CLI commands, but they have a job to do, provision a new server port, a new access port in the network. This is a way of providing a point-and-click interface where you can enter these parameters, and CloudVision will then take those parameters, feed them through a build process, and generate the necessary config. A couple of things that this new Studios feature introduces is something called tags. So this is a way of tagging devices and interfaces using what we're calling this tag-based data model. So that allows us to create new ways of assigning parameters to devices. So we have the strict hierarchy of containers and configlets. This allows much more flexibility. So we can now select a tagger device, for example, with a particular function, regardless of where it sits in the provisioning tree. Studios includes, or the beta version mentioned, ships with some built-in studios. So these are built by the Arista team for common workflows. So we've got, for example, Interface Manager for managing switch interfaces. But we've also got some more complex studios as well. So a studio for generating configurations for leaf-spine fabrics or EVPN configurations and services, both the underlay configuration and the services. And these are built on Arista validated designs as well. So this is a way that you can spin up these designs quickly using validated templates. But they're also customizable as well. So if you have a requirement to build your own studio, for example, a particular feature that you're interested in automating and you want to provide a point-and-click interface for your operators, that's also possible with Studios as well. So it's basically a way of, you can define the input parameters, the template logic behind that, or you can make use of the built-in ones. This works alongside existing provisioning processes, so it should be seen as an evolution. If you're happy using the existing tools, so configlets and containers, that's absolutely fine. This builds on top of that, and we see a lot of benefits in extending that. As mentioned again, this is only in beta at the moment, so you do have to turn this on via a toggle on the settings page. But this is now a good time, if this is something you're interested in provisioning and new workflows for provisioning within CloudVision, it's an excellent time to switch this feature on try it out in your lab, provide feedback to the Arista team or your account team if that's something you're interested in. That would be really useful. Okay, so we have a demo that our colleague Hugh will go through, but before we go to the demo, I just want to talk through some of the concepts, because Studios does introduce some new terminology, some new concepts that you'd need to be aware of. So what I've done in this diagram is showing the existing provisioning stack within CloudVision that has been there, say, since 2015. So may be familiar with some of you that have used the product. We have the configurets, so either static, so this is static EOS syntax. We also have the configuret builder method of getting configurets generated. These flow down into what we call a design config. So every device in the network that's managed through CloudVision has what we call a design config. And that's a merge of all of the assigned configurets. And then once that's generated for the device, it flows down into our task and change control system. And that's where we actually push it out to the devices using the API. And this can all be driven either through the web interface or via API. And we have customers doing both of those, or a combination of that. Studios adds on some additional items above this, so you can see it as a natural, it flows into the existing provisioning logic. And we'll go through each one of these in a little bit more detail. So the first item is a workspace. Now, what is a workspace? Why do we need it? So this is what we call a staging ground for any change that we make through the provisioning process. So if you've got a job to do, you've got a new port to add, a new switch to deploy, the first thing you would do when using Studios is create a workspace, and that's a temporary staging ground for the change. So you'd assign it a name, and it doesn't mean that you have to commit that change straight away. Maybe you can work on that in the morning, come back to it later. That workspace will be pending until you've committed it or pushed that further, or you can abandon it at that point. We'll talk about why workspaces are important and the way that works, allowing multiple operators as well to work within CloudVision. But basically, as it says here, workspace is created when a user is preparing to make a change, and also when you're modifying tags as well. So I mentioned tags also are a central part to this new provisioning workflow as well, where you have to have tags assigned to the devices and interfaces that you want to manage through this new system, if this is something you'd want to do. Next, we have the studio itself. So this is where you interact with CloudVision via the point-and-click interface. As I say, there's some built-in studios, but you can also create your own if you want to change the layout, make drop-downs or checkboxes. That's available to do that within the studio definition. Each studio manages a particular configuration item. So, for example, you can create a studio for NTP or to create routing policies, etc. And I say there's both built-in and custom. You can take the built-in ones and customize them, or create one from scratch. As I mentioned, tags. These are label value pairs. So, for example, we could assign a role and then spine or data center in London. They're completely flexible how you want to structure your tags. But it's a way of managing the devices within the system, because although we've had the container model for quite some time, it is restrictive in some cases. It doesn't always account for certain scenarios where you want to apply a particular configuration against certain devices with certain requirements. As I say here, arbitrary grouping of devices, and we can also search by tags as well. Okay, so once you have prepared your change within the workspace, and then a workspace can span more than one studio as well, so another key point. So it's not a one-to-one mapping. You can create one workspace, but then modify the inputs for various studios within the same time. Once a studio has been populated with the input data or drop-downs, etc., we can then go forward with a review and validation process, and we do that through what we call submitting the workspace. And we'll see that during the video demo we have. As soon as a workspace is submitted and it's been approved and pushed, it becomes part of what we call the mainline code within the data model. So this is maybe a familiar term in software development, where we have a code repository, we fork that, we branch that, and then we make our changes and we commit that back up to the main line. So this is a similar sort of philosophy that you have within CloudVision. And this will hopefully come through during the demo as well. I think on the next slide, I think we have the demo. I think it may start. So I'll hand over to Hugh if your microphone's working. Hugh. Oh no, so we've got one more before the video. Sorry, I thought the video was going on that one. This is just trying to illustrate really the idea of the workspace concept. So at the top of the screen, we have the mainline configuration. We create a workspace, we make our changes, and we commit that back up to the mainline. This is trying to illustrate that process really. It allows multiple operators to stage changes without blocking each other. And then, as I say, it flows down into the design config, and you can apply the changes using all the standard tools that you have within CloudVision. Okay, I think the video, hopefully, is it the next one? Oh no, excuse me. Do we have to play the video manually? It's not. One more. Oh, there we go. Okay, over to you.
I think it's playing already, right? So we'll be quick. So what we're doing here is we're actually creating a studio and workspace. So what we're going to do is create a change, make some users up. We're going to create a couple of HR users and a couple of dealing desk users in this scenario. So first thing I'm doing is building a workspace. So I already clicked on it, selected the studio, and I'm just creating a workspace. So basically, as Paul said, this is just an area for you to work on. Then I'm going to pick the studio I want to actually use to configure it. So we're going to use the interface configuration studio here. And that just allows us to play around with parameters that configure interfaces. It might be the IP address, it might be the VLAN, it might be anything like that, but they're all in the templates. So as an operator, I don't actually need to know what they are. Next thing I need to do is actually constrain my change. So I'm going to select a few devices in the network that I know I want to make my changes on. These are the ULEAFs in the network. These are there purely for the users to connect to. So I'm just going to do that. So I just constrain my change to those particular leaves, and then I'm going to pick 3 of them, and you can see it's filtered it and said, right, these are the ones I'm going to select and use. Now, when I go to my change, I go find the leaf that I want to play with. In this case, it's ULEAF 1, because that's where my HR team is. I'm going to pick an interface, in this case, interface 7, and I'm going to set it up and enable it, and then I'm going to provide a profile for it. Now, as an operator, I don't need to know what that profile looks like. All I need to know is which profile I'm going to put on it, and then any additional information I want to provide it. So in this case, the HR user's name. Similarly, I'm going to do the same thing again on interface 8. Just do that, provide the same profile, give them a name, and job's done for HR. Now, I'm going to go back up one level and find my other device for the dealing team. They're on a different leaf, they're on ULEAF 3. And here we're going to do the same thing. We're going to find them, we're going to put them on interface 7 and 8 again. But this time, once we've enabled the interface, we're going to select a different profile. As an operator, I don't need to know what that profile's doing. I just need to know which profile I'm picking up. So I picked up a trading desk profile, and that's going to basically configure the port for a trading desk position. And then again, I give the port a description. In this case, just where Samantha lives and what she's doing. Similarly, we're going to create a second dealing desk, but this time we're going to do it for, I think it's James. Here we go. Here comes James. Oh, Susan. And then now I've done that, what I'm actually going to do is review the workspace. So in the background, what CVP is doing is it's checking those inputs to make sure everything's correct. It's then going to build the configurates and make sure they are valid and check them against the switch to make sure the configuration is valid. Once it's done that, it's going to show us the configuration so we can see what's actually changed on the switches. Now, if you look at these, you can see for the HR desktop team, we've just applied them to a particular VLAN. And as we move down for the other switch, you'll see that actually the trading desk team is using a trunk port. Now, as an operator, I didn't need to know any of that information. All I needed to know was what profiles to put on it. And now these can be defined by your engineering teams. Once we're happy with that, we can submit the workspace, and that now commits it into the mainline code, as we were talking about earlier, and puts it into the change control. And all of this was done without actually having to know anything about the CLI or having to know anything about what's going on in the background. So now we have 2 changes. Now here we're going to apply a template that Paul was talking about earlier to show you how these work. So you've got my 2 tasks that I was going to commit. I'm going to pick up a BAU low impact template and apply that to the change. And what that does now is it populates all the other bits and steps of that change I want to do. So I'm going to take a snapshot, I'm going to check which switch I'm on, I'm going to apply the task and take a second snapshot at the end of it. So what I've now got is a fully populated change that I can repeat time and time again without having to worry about, did I miss a step, did I remember a step, did I get distracted? And just for the fun of it, we're going to schedule it. This gives me a bit of time just to run off if I get this thing wrong. So what we're going to do, it's not 5 o'clock, you might guess this is video. We're going to set it for 2 minutes into the future, just to show you how this works. So a little bit of clicking to get the time set. And once I'm happy with it, I'll apply it. It shows me when I'm going to commit the change. We then go through the approval process, and it shows us exactly what we're doing. So this may be done by a different operator, so they can review the change before they actually commit it. We can now see that the change has been approved. If I make any changes to this from now on, it will change the approval status from unapproved to approval pending. So somebody can't sneak in here after it's been scheduled and make the change. So you can see now in our change controls, we have that approved change. It's waiting there. It's going to sit there for about 2 minutes. So we've got about a minute and a half before this actually commits. So is there any questions about this so far? All kind of happy with that? All very straightforward. If we're using the studios and you actually build your own, that doesn't necessarily have to be done by the operator. So if you want to create your own studios, that can be done by an engineering and architecture team who actually define all the policies on the network, leaving the operators free just to apply them. With the interface templates, we could have actually created some other profiles, and they could have been done by a lower level team, like an engineering team, leaving the operators again free just to worry about the templates themselves. So in a minute, what you'll see is this is going to click from being approved to start running. There we go. So it's just gone from pending approval, and it started into the running one. So let's click on it and have a look and see what it's doing. So we've been a little bit slow, but you can see it's already gone through and taken the first set of snapshots. It's already done the check on the switch to make sure it's actually a VOS, because I'm running this in my lab, so I don't want to be destroying the production switches. And then it's committed the change and run snapshots afterwards, which just leaves us to be able to review those. So I'm going to pick on leaf 1, go to my snapshots, find the change control snapshot, and what it's going to bring up is show us all the commands it's using. And then I can compare this change, both pre and post change, to see what actually moved. So in a minute it's showing both post changes, there's no changes. I'm going to pick up the pre-change snapshot, and then we can see the diff between the two. So now I can verify that what actually I made the change on is exactly what I was expecting to see. And with all of this, once it's done, if I want to, I can export these snapshots and things out to any kind of change management system I've got to put them in with the documentation. Okay, that's the demo. Any questions on that? Yes?
When you run these workspaces, can you pull in information from, say, an external resource? I'm thinking here of things like IP address management system to assign the appropriate IP addresses for interface with the deploying switch.
I love it when you have some good questions. Yes, you can. In the beta version of it, we don't have that yet. We're hoping to get that into the general release thing, but yeah, the way the Studio templates work in the back end is they're actually using either Mako or Ginger 2 templating languages. With the Mako language, you can put quite a lot of Python scripting and logic into those natively. So you can do calls from that. And then we're hoping in later versions of the Studios to actually put those into our data inputs as well. Okay, any other questions? And I believe it's coffee time.
I think so, yeah. Yeah, just in terms of summary, we have, if you want to learn more about CloudVision, we have some good white papers on the website. There's also a CloudVision Studios white paper, which goes into some of this in a lot more detail. And as I mentioned earlier, we've got the TOI links as well. So yeah, that's all. Thanks very much.